Hi everyone, myself Manasa SR, USN 1BE20IS020 from Sri Venkateshwara College of Engineering. I am from the Department of Information Science and Engineering. Today I am going to explain about my technical seminar topic on a secure and flexible blockchain based offline payment protocol, and under the guidance of Dr. Shalini ma'am, who is Associate Professor of Department of Information Science and Engineering. The contents are introduction, related background, working and implementation, future announcements, conclusion and references. Now let's know the introduction. The blockchain technology has become a key instrument is removing trusted intermediaries. Research in the field of blockchain technology considers security, scalability and decentralization to be vital concepts. The existing blockchain implementations have yet to achieve these three properties simultaneously. Offline payments were introduced to promote transactions that take place offline and are reclined with network connectivity. Off-chain transactions play a vital role in bringing about offline payments to blockchain-based scenarios. They leverage an off-chain network of channels to support offline payments. Previous published studies on offline payment solutions for blockchain lack standardized threat model and security model. Such threat models should cover the various security threats in offline payment solutions for blockchain. In this paper, we hypothesize that two offline parties which experience intermittent on-chain connectivity can engage in backchain based off-chain transactions without sacrificing security and flexibility. We introduce a secure and flexible protocol that realizes offline payments in offline blockchain based solutions. To improve the security of our protocol, we leverage platform against trusted execution environments (TES) that achieves trusted computations and secure offline wallet interactions in distributed settings. We evaluate the performance of our proposed construction over the Intel Software Guard Extensions (SGX). Our contributions are as follows. First is effective trade off between security and flexibility. Second, characterization of comprehensive threat model. Third, security source code provisioning and evaluation methodology. Now let's see the related background. This section reviews the literature on offline blockchain based payments. Currently, research on the subject has been focused on either security or flexibility. Existing constructions fail to simultaneously meet the desired requirements of security and flexibility. Now let's see first one, offline payment constructions based on payments channels. The concept of payment channel originates from the Lightning Network, an off-chain expansion scheme of Bitcoin, which later evolved into more general off-chain channel schemes that exhibits Turing completeness. Describe the specific workflow of offline wallets in payment channel based schemes. The payer and the payee must first create a channel online through two multi-signature wallets. Recharge the amount in the multi-signature wallet and offline spending and mortgage. Then both parties can leverage the channel metadata to conduct offline transaction. Other offline payment schemes. A recent offline payments protocols advocate flexible interaction between random payers and payees over intermittent on-chain connectivity. They generate key pairs for offline wallets through the master public key property of hierarchical deterministic HD wallets. In this work, The wallets only need to store and back up the master private keys, not the individual private keys generated for each offline transaction. They aimed to address storage scalability issues where the size of the offline wallet grows with the storage of individual private keys. When multiple offline transactions are performed, besides their work utilizes an interactive signature protocol to ward the cryptographic attack on the offline wallets. Now let's move on to the working and implementation. Our protocol enables the interaction between five main entities of interest. First, offline payee, the trusted execution environment means TEE, then rich execution environment REE, and the on-chain smart contract. Uh, Now first see the user. Each user requires an offline account to participate in our framework. Such an offline account possesses an address that is generated via the offline account public key. The offline payer must perform an initial on-chain transaction that credits its offline account. Whenever the payee receives an offline transaction, it verifies the integrity and validity of the payer state using embedded metadata. When the offline payer captures a receipt of transaction confirmation from the offline payee within the given lock time, it updates the balance of its off-chain state and the offline transaction is considered successful. If no confirmation is received within the given lock time, the offline payer assumes that the transaction failed. Then move to the trusted execution environment. In trusted execution environment, it generates an offline account for the new user, a public key or private key. It stores the off-chain state of the offline account and holds the manufacturer's public key, MPK. MPK means manufacturer public key. The TE verifies the integrity of operations that aim to update the off-chain state. Now let's move to the REE. REE means Rich Execution Environment. The REE sits between the TE and the on-chain smart contract and serves as interface between both. The REE provides functionalities that supports a set of operations performed by users, such as the offline account initialization, the recharge and withdrawal of chain accounts, the processing of offline transactions, the on-chain verification of off-chain states, and the cancellation of user accounts, etc. Then move to the on-chain smart contract. Our scheme an on-chain smart contract to update the on-chain state users. In our protocol, every successful state transfer from on-chain to off-chain requires attestation from the on-chain smart contract. A transaction receipt, on-chain smart contract, and a transaction receipt. The on-chain smart contract is written in a contract-oriented language, CQL, COL, and performs verifiable calculations according to the predefined set of rules. In this, CSK generator means private key generation. PK means public key generator. Now let's move on to the future announcements. First one is lightweight client support. Implementing lightweight client support to enable devices with limited resources to efficiently interact with the blockchain network, enhancing accessibility and scalability. Second one is threshold signatures to enhance security and decentralization by allowing multiple parties to avoid to joining signature transactions, mitigating single points of failures and enabling secure offline transaction. Third one is offline identity verification, implementing offline identity verification mechanism to securely authenticate users during offline transaction, uh, ensuring privacy and preventing unauthorized access to personal information. Fourth one is improved privacy solutions, enhancing privacy solutions by incorporating advanced cryptographic techniques such as zero knowledge proofs or ring signatures to provide stronger connectivity and confidentiality for transactions on the blockchain. Fifth one is user education and adoption initiatives. User education and adoption initiatives, implementing user education and adoption initiatives to increase awareness and understanding of blockchain technology. Sixth one is standardized protocol and regulatory compliance to establish a framework that fosters trust, interoperability, and legal compliance across jurisdictions of offline payment transactions. Now let's move to the conclusion. The main goal of this paper was to determine whether two offline parties can proceed with the blockchain based offline payments without sacrificing security and flexibility. To achieve our aim, we designed a flexible and secure offline payment protocol under partial network asynchronism. Our work leverage on chain smart contracts during good on-chain connectivity and secure offline chain transactions that leverage comfortable TEs under bad on-chain networks. We characterized a threat model for blockchain-based offline payment over an asynchronous network. These are the references. These are some of referred papers for recent topic. The first paper is a secure and flexible blockchain based of payment protocol. So a summary of the paper is detailed about working process. The next paper is applications of blockchain in the Internet of Things, a comprehensive survey. The summary of the paper is blockchain achieves immutable and secure records through distributed consensus algorithms. The next paper is a scalable blockchain framework for secure transactions in IoT based dynamic applications. The summary of the paper is the approach was developed to achieve dynamic device management, efficient transaction verification, conditional traceability, data security, and privacy preservation. Now let's move on to the next paper. Blockchain based payment channel networks, challenges and recent advances. The summary of the paper is this new type of network resembles traditional networks to some extent but also calls for PCN specific research to improve their scalability and performance given their special characteristics include the requirement of privacy. Thank you.